Hello everyone and welcome back to IPv4 addresses part 2, and let's just get right into it. So for each IPv4 address there is a network portion and network host, and just like before, an IPv4 address is a 32-bit hierarchical address that is made of a network portion and a net host portion. And as you can see in this picture here, it shows IPv4 address in decimal and binary form, and you can see which octets are part of the network portion and which part of the are in the host portion. When it comes to the subnet mask, this is used to identify the network and host portion of the IPv4 address. The IPv4 subnet mask is used to differentiate the network portion from the host portion of an IPv4 address. When an IPv4 address is assigned to a device, the subnet mask is used to determine the network address of the device. The network address represents all the devices on the same network. When it comes to the prefix length, the prefix length is a number of bits set to 1 in the subnet mask. It is written in slash notation, which is noted by a forward slash followed by the number of bits set to 1. So you look at this graph here, it shows the subnet mask, 32-bit address, and then the corresponding prefix length. The easiest way for me to figure out what the prefix length is, so if you look at this binary address, you see it just basically you just have to count up the number of ones in this binary. So as you know, each field here is an octet, so it's 8 bits here, so there's 8 ones, and that would be 8. And same with 16, there's two different octets with ones here, so that adds up to 16. So that's the easiest way for me to figure out what the prefix length is. And then we'll get later into how to get these decimals into binary and vice versa. Determining the network with logical AND. A logical AND is one of the 3 Boolean operations used in Boolean or digital logic. The other 2 are OR and NOT. The AND operation is used in determining the network address. And when the 1 and 1 is equal to 1, 0 and 1 is equal to 0, 1 and 0 is equal to 0, and then 0 and 0 is equal to 0. So basically, the easiest way to remember that is just if you have 1 and 1, it's equal to 1, and then the rest are 0. So if you look at this graph here, if we have the IPv4 address and then the subnet mask, we convert those into binary and then put them there. So if you see, as you can see here, a 1 and 1 is equal to 1, and then another 1 and 1 is equal to 1, and then 0, 1 is equal to 0, and so on and so forth. So as we know, as we remember, just 1 and 1 is 1, and then you go down here and put these in each bits here. And then once you get all these binary down here, you can convert them into decimal, and you could figure out the IPv4 network address. When it comes to converting the addresses to binary from decimal, if you look at this here, this is the easiest way to do here. So say let's get 10 here. So we look and see here. So we put 10, you see does 10 go into 128? It does not. And then 64 and 32, 16, it's all no. So you have zeros there. And the first number it does go into is 8. So we put a 1 there, and then you just subtract that. So 10 minus 8, we have 2 left. So 2 doesn't go into 4, but 2 does go into itself. So we have a 1 there, and then 2 minus 2 is 0. We leave that there, and it's obviously a 0 there. And just like 11, doesn't go into 128 or 64, 32, 16, but does go into 8. So we have 3 left, and put a 1 there. And then 3 doesn't go into 4, but doesn't go into 3, put a 1 there. Or goes into 2, excuse me, put a 1 there. And then we have 1 left, and it goes into itself. So I have that. Same thing with 12 here. Doesn't go into 128 or 64, 32, 16. Goes into 8, have 4 left, and goes into itself. Put a 1 there, but I have 0 left, so it doesn't go into 2 or 1. and you can see that binary there. So each column here, each column there has a number. So that's the 128, 64, 32, 16, 8, 4, 2, and 1. And then lastly for 99, doesn't go into 128, but does go into 64, and that's 35 left over. And then 35 does go into 32, so put that there, and we have 3 left. Doesn't go into 16, 8, or 4, so do that, and we have 3 left. Goes into 2, obviously, and then we have 1 left, and it goes into itself, and we have that binary there. So basically, the number you have, you want to see, start at 128, and work your way down and see if it goes into that number. And then if it does, you subtract, and you go from there. It's pretty simple stuff once you get the hang of it. Right, so we have a short quiz. So number 1, what does 1 and 0 equal to regarding the logical AND? And then number 2 here, what is the prefix length of this 32-bit address? So we got 8 ones in the first 3 octets, and then 3 ones followed by 5 zeros in the third octet, or fourth octet. And then number 3, what are the other 2 Boolean operations used in Boolean logic? And then number 4, what is the binary address converted from this decimal address? So we have 192.168.11.5. And then 5, what is the decimal address converted from this binary address? Got all this here. So like I said in the last video, I encourage you to pause this video to take your time and answer these questions before we get into the answer key here. And then we got the answer key. So answer to question number 1 was 0. And then number 2 was /27. Number 3 was or and not. And then number 4 we had 1, 1, and then 6, 0 followed by that. And then 1, 0, 1, 0, 1 followed by 3 zeros. Then we had 4 zeros, 1, 0, 1, 1. And then next one we had 5 zeros, and then 1, 0, 1. And then for number 5, the decimal for that binary before is converted into 172.32.255.163. So that's all I have for these 2 parts here of IPv4 addresses. Hope you guys learned a lot, and I'll see you next time.